Hey guys, just going to finish off our lesson on chromatography the other day. So we were talking about thin layer chromatography. In this example, we've got a stationary phase that is made of silica and a mobile phase that is hexane. The stationary phase silica is polar and the mobile phase hexane is non-polar. Okay, so we've got our thin layer here. Remember, a pencil line is drawn near the base of the plate. Okay, the sample is then injected onto the plate, and then the plate is placed into a beaker containing our mobile phase, hexane, and the components are allowed to separate. Once all the components are separated out, the thin layer is removed and dried, and the distance travelled by the solvent, which we call the solvent front, is measured, as well as the distance travelled by each of the separated components. Okay, in this example here, the distance moved by the solvent front was 4 centimetres. Okay, and the distance measured for each of the components were 1.5 centimetres, 2 centimetres, and 2.5 centimetres. From these values, we can calculate what we call an RF value, which is basically just a ratio between the distance travelled by the components and the distance moved by the solvent. So it's a very straightforward calculation. For component 3, which travelled 2.5 centimetres, basically we divide 2.5 by 4, and this will give us our RF value of 0.625. For component 2, which travelled 2 centimetres, our RF value is 2 divided by 4, which is 0.5, and for component 1, which travelled 1.5 centimetres, our RF value is 1.5 divided by 4, which is 0.375. Okay, now from this information, because we've got a non-polar mobile phase, the component that travelled the furthest, component 3, is therefore the least polar component, okay, because it travelled the furthest along the plate, meaning it had the strongest interaction with our non-polar mobile phase. So in this example, non-polar components will travel the furthest due to their level of interaction with the mobile phase. That's basically how thin layer chromatography works.